Hello everybody, my name is Toshihiro Fuji, Graduate School of Science and Nabu Yoichiro Institute of Theoretical and Experimental Physics. Today, I'm going to talk about the hunting for the highest energy cosmic ray. So cosmic ray is an energetic particle in the universe, and it was discovered by Victor Francis Hess in 1912. He was awarded the Nobel Prize in Physics 1936. And the cosmic rays are dominated by proton. This is a tiny, tiny particle, and also helium, electron, and heavier nuclei. So before discovery of the cosmic ray, people believed the radiation comes from the ground. And Victor Francis Hess tried to measure the radiation as a function of the altitude using the balloon, as you see like this one. So surprisingly, as a function of the altitude, the radiation is increased. People were thought it should be decreased as a function of the altitude, but surprisingly it was increased. And then they realized the radiation comes from the universe. After the discovery of the cosmic ray, people are measuring the energy spectrum up to the 10 to 20 electron volt, which is the most energetic particle in the universe. This is a measured result of the spectrum with multiplied by the factor of energy e to 2.6. And you can see the structure of the brakes, so-called knee and ankle and two region. So as a function of the energy, frequency of cosmic rays gradually significantly decreased. And for example, at the region of the knee, with the energy of 10 to 15 electron volt, this is the only particle per square meter per year, so-called knee region. And you see that some spectrum is break these energies, and then there is another knee, and then ankle structure and two structure. This region is the most energetic particle from the universe. The energy is 10 to 20 electron volt. This is only one particle per square kilometer per century. So this is the really energetic particle, and people try to accelerate such particle in the Earth, but we can achieve only the 10 to 13 electron volt. This is 7 order of magnitude different what we observed from the universe, what we achieved from the ground. But problem is this energetic particle is extremely infrequent. To detect such energetic particle, we need a huge effective area, such as 1,000 square kilometer, and also long time observation over the decades. The most important question of the ultra high energy cosmic ray is what is the source of such energetic particle? The origin of nature are still largely unknown. This is one of the most important mysteries in the astrophysics. The possible candidates are proposed, like a really energetic phenomena in the universe, such as the gamma ray burst, or active galactic nuclei, neutron star, and galaxy clusters. The other intriguing origin is exotic physics. This is a dark matter or unknown particle or topological defect in the early universe, magnetic monopole, and cosmic string. This is a beyond standard model. We would like to find such the exotic scenarios. To find the source, we would like to proceed the charged particle astronomy. The most energetic particle is fewer diffraction in the galactic and also extragalactic magnetic field. So in the lower energy of the cosmic ray, such as 1 electron volt, which is 10 to 18 electron volt, this is largely diffracted in the galactic magnetic field. This is the simulation of the backtracking of the charged particle. This is our galaxy, and this is the location of the Earth. So low energy case, we cannot point back the arrival direction, but if we go to the 10 eV, which is 10 to 19 electron volts, the arrival direction is point back to the source. This is the indication of the source of the origins. So the diffraction angle are defined is this formula. If the energy is 10 electron volt, and assuming the proton primaries, the bending diffraction angle is 10 degrees. And if you go to the higher energies, for example, 10 to 20 electron volt, This is only a factor of the 1 degree bending. It can be the point back to the source of the cosmic rays. So this is the image of the cosmic ray astronomy. So this is the usual low energy cosmic ray is bending, but in the case of the extremely high energy cosmic ray, this is point back to the source to see the such as possible candidate, active galactic nuclei, starburst galaxy, and centaurs A really nearby active galactic nuclei. We would like to where is the source and where is the origin of the such energetic particle. So to detect the cosmic ray, we would like to do the observing the extensive air shower, which is the most energetic particle interact with the atmosphere and creating a lot of the secondary particle like this one. So to catch the such extensive air shower, we built the 2 types of detectors. One is the fluorescence detector, and the other is the surface detector array. So surface detector array can measure the particle on the ground with spacing like this one. And this surface detector can detect the cosmic ray penetrating in the detectors. And on the other hand, fluorescence detector can measure the side view of the extensive air shower. But fluorescence detector can measure only the moonless clear night. Using those 2 techniques, we have built the telescope experiment in the Utah, USA. This is the international collaboration of the 140 researchers from 8 countries. It is the largest cosmic ray detector in the northern hemisphere, with effective area of the 700 square kilometers, constituting the 507 surface detector array, and also surrounding the surface detector array, we built the 38 total fluorescence detectors. The continuous operation has been started from 2008. So we are now upgrading of that experiment, dubbed the TA times 4, which will increase the effective area of the 4-fold, like this area and this area, to newly installing the additional surface detectors. So this is the construction and the deployment of our surface detector array. So this is the scintillator. This is the handmade detectors. And we use the scintillator and also fibers. And the charged particle penetrating this scintillator, this emitted tiny photons. And this collected by the fibers and then recorded by photomultiplier tool. Those detector is operating the standalone operation in the Utah desert, like this one, using the solar panel and battery and electronics. And then the detector was deployed by helicopter. So this is assembling detectors just before the deployment. As you see, our detector is like here, and we need to install the panel, solar panel, batteries, and the electronics, and ready to deploy. And then we install by helicopter, like this one. As you see, this is our detector towed by helicopter. And then before deploying the detector, we're walking around the desert and checking the GPS and check the position, and we put the sign to be installed. And then after the few days later, and we travel to the site, and then finally we catch that detector at the ground. As you see, we need to rotate to see the sun. It means the solar panel have to face to the south, and then we install like this one. After the 2008, we continued operation up to the now, more than 15 years. And finally, we hunt the most energetic particle in our experiment in recent 15 years. It was catched at 2021, May 27, at the morning just before the sunrise. The total 23 surface detectors triggered sequentially in time and spacing. This is the position of the individual detector. And then this is the recorded waveform from this side and that side. It means the cosmic ray extensive air shower coming from that direction and hit it from here to that direction, and really sequentially coincidence within the microsecond orders. The cosmic ray footprint is extended about 10 kilometers in circle, and considering those information we evaluated, it was 244 exa electron volt. So this is the artistic illustration of the Amaterasu particle, and the really energy particle from this direction, and making a lot of the secondary particle, so-called extensive air shower, and then hit the 23 total counter on the ground. The most intriguing question is where comes from. So the arrival direction of the Amaterasu particle in the celestial coordinate is indicated like this one. And surprisingly, the arrival direction of the Amaterasu particle coming from this direction, injected from the local void. This is really away from the possible source candidate from the astronomical object. So as we know, there are large-scale structure in the nearby universe located in this direction. And this color map shows a cosmic ray flux from the nearby possible candidate. The arrival direction is Amaterasu particles is located nothing regions, so in this direction. So of course the TA times 4 will getting the more data and to clarify the origin of the such particles. Telescope array experiment is the largest cosmic ray detector in the northern hemisphere. The operation has been started from 2008. So let me summarize my talk. So cosmic ray are energetic particle in the universe. The frequency is low as a function of the energy. And above the 10 to 20 electron volt, this is only one particle per square kilometer per century. We would like to do the charged particle astronomy above 100 eV, because such higher energetic particle is less deflections in the galactic magnetic field. And we have started the telescope array experiment from 2008. And finally, we detect really energetic particle from the universe. This energy is 244 eV, dubbed Amaterasu particle, from unexpected direction in the universe. So we are now ongoing upgrade, so-called TA times 4. It will increase the effective area fourfold, and hope this Amaterasu particle and additional such energetic particle will be pave the way for finding the origin and source of the highest energy cosmic ray. Of course, we happily welcome new colleagues in our research field. Thanks.